In this tutorial, you will learn how to conduct post hoc testing. Post hoc testing is done if you reject the null hypothesis on an ANOVA test. Remember, the null hypothesis for ANOVA is that each group mean is equal. If we reject this, that indicates that we believe that at least two of the group means will differ. Post hoc testing is done to determine which group means differ. To conduct post hoc testing, we will compare each pair of groups. So we call these pairwise comparisons. To know how many comparisons you will have to do, you can use the equation k times k minus 1 divided by 2, where k is the number of groups. So here we had 4 groups, so 4 times 4 minus 1 divided by 2 gives us 6. So we have 6 comparisons we will have to make. Each of these is an independent group, which was one of the assumptions of ANOVA. So to conduct these pairwise tests, we will run independent samples t-tests repeatedly. To do this, go to Data, and then Data Analysis. And we will continue running tests, assuming unequal variances, and click OK. Variable 1 range will be our first group. Variable 2 range will be the group we want to compare to it. I included the labels in both of my groups, so I will check the labels box. And I will output my range to this same sheet and click OK. So this is my first comparison. Now I will repeat this for the other 5 comparisons. Now that we have completed all 6 sets of comparisons, we can determine which groups significantly differ from one another. Because we did the same test repeatedly, we want to do a correction to account for the fact that we've increased our type 1 error rate by repeatedly doing the same test. This correction is called the Bonferroni correction. To apply it, we will take our original alpha level of 0.05 and we will divide it by the number of tests we completed, which was 6. That gives us 0.008. This will now be the p-value we will compare each of our tests to make the decision if our groups significantly differ. We will compare the two-tailed p-values for each test because we had no specific hypothesis as to which groups differed in which direction. So we will compare each two-tailed p-value to this value. I have highlighted all of the two-tailed p-values in order to make it easier to see so that we can determine which groups significantly differ. As you can see, only one group's comparison has a p-value for the two-tailed test that is less than 0.008. It is this test, the middle versus oldest. Therefore, we can conclude that this is the only test which includes a significant difference. So middle and oldest children significantly differ in their phone time use. However, none of the other groups significantly differ in their usage of the phone.